Hello everyone, I am Abhishek and today we are going to solve house robber problem. So let me explain you the problem first. So the problem says you are a professional robber planning to rob house along a street and each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected and it will be automatically contact the police if two adjacent houses were broken into the same night. So given a integer array representing the amount of money of each houses, return the maximum amount of money you can rob tonight without alerting the police. So what the question is saying is that like here the question has given us some arrays and in the array it is given this there are like total of four houses. So in the four houses how many money are there, how many money you can collect from these houses. And it is also mentioned that if you rob two adjacent houses, for example if you rob one and if you rob two also, then you will get an alert and your robbing will be failed and you will be caught by police. So it's a story kind of thing, but we will bring here into the coding stuff how we can solve this question. So the question basically says like from this array we need to take the maximum, we need to calculate the maximum amount we can generate by uh, taking this one, by taking this one or taking this two, taking this three and taking this four. And how can we take this? Like if we take one, then we cannot take two, we have to take from three, and if we take three we cannot take one. So like that. So if we don't take one we can take two also. So here our question like break down into a peak don't peak pattern kind of stuffs. So we can either take one or we can either take one or not take one, we can either take two or not take two, we can either take three or not take three, and we can either take one here and not take one. So our question brings down into some sub problems into take and not take. So let me explain you in a better way. Let me explain you one more time here. Like there are these four houses, and they have some money, and we need to collect the maximum amount of money. So from if we collect one here, we will not be able to collect two, and we will directly go to three only. We can collect three only, and we also have the option that we can either collect here three or not collect three. We can either go to one also here. So for example what I am trying to say is, for suppose we have here total of let's say here we don't have any amount, then if we take here one from the first case itself, if we take it, then we cannot take the 2 itself. We need to take either 0 or we need to take either 1. We need to take either one. So if I come to 0, if I take the 0, then I cannot take the 1. So for this, if I take 1, then I will have only one amount 1. I can collect only amount 1 in that night. And if I don't take 1, then I can go to 2. Then on the 2, if I taken 2, then I cannot take this 0, I can take only 1. So I can have total of 3. But if I don't take 2 also here, then I can go to 0 and then 1. I can go to 0, I can take 0 or I can take 1. So if I don't take 2, like I will only generate like 0, there's no point of taking it, and 1 I can only take 1, and there is like nothing left after that. So maximum will be 1 only. And one more case I want to show you, that if I take 1, then it is confirmed that I cannot take 2, but it is not written here that I have to take the adjacent one like 0. I can take 1 also. So if I take 1, I can either take 0 or either take 1. Like if I don't take 0, then I can take the 1. So that's why here I can take 2 directly. If I take the 1, I can skip this both and directly I can take 1. So I am following the adjacency rule that I am not collecting any amount. If I've collected from 0 index, I'm not collecting the amount from first index. I'm collecting from the uh, this third index, 0 1 2 3, yeah, third index. So it is not so what I basically wanted to say is that in the question it is not told you that you if you collect one then you have to collect two, have to collect this adjacent one only. Means uh, skipping the adjacent one, one more index which is coming like 0, it is not confirmed that you have to take it only. You can either decide to take this or not take this, and you have to uh, write your or generate the answer in such a way that you generate the maximum amount. So for that actually we need to have our peak don't peak pattern. We will write our function helper, and in the helper we'll pass the nums and in the nums let's first make it an equal to nums dot size. So here I don't need to pass the size first. I'm passing the index from which I wanted to start, and then I will write my helper function here. And the function will have both nums array which will be taken by reference and the index idx. So what I was going to say here, like I will have two cases here. If I take it like num sub I idx, so whatever index it is there in for whichever index I'm calculating it, like either I can take it. If I take it, then my sub problem will become index plus 2, index plus 2, as because I cannot take the adjacent one. And if I don't take it, not take part, if I don't take it, I am not going to take the money from here, then I can take the money from the next one, and we need to return the maximum amount we generate from the take and not take, not take. And we need to write our base condition. So base condition will be whenever the index will reach greater than equals to nums dot size, then we need to return 0 because there is no money after that. So we can return here 0 and we can return our answer from here. So basically it will give the answer correct here, but here the time complexity will be exponential as this helper function, like for each function call, this recursive call, there are two functions are being called. So it can go to like each function called two functions are called. So like each function is generating two other functions, so it will be 2 into 2 into 2 into 2. So how many like two functions will be called? Total number of n. What is the size of the n? Because we are doing it like index and we are going to n size, so that's why here it will generate 2 into 2 into 2 into 2 to the to n times, so it will be 2 to the power of n, so which is exponential, which is not acceptable. So that's why we do the recursion with memoization. So this is a DP thing, memoization. So what we do is like we make one vector DP with size n and we have -1. So we are initializing the array with such value which can never come here. So here it is already written that our num's length is also till 100, and the value which are given are all are positive, so there is no chance of getting what negative number. So I am assigning all the value to -1, because I know that the -1 can't be generated, -1 can't be generated from any of the sub problem. That's why. And next I will pass my dp here, pass the dp here with reference, because I want the same dp to be changed. And here we will just assign our value, and if we found that the dp of index is not equal to -1, if it is not equal to -1, as we have initialized it earlier by -1, and if it is not -1, then we have assigned some value to the index. That means we have already calculated the calculated for this index value. So why we do the dp? Because we know that there will be like many overlapping sub problems for sure. So to avoid that sub problem to be calculated again, if only once we have calculated, and to avoid that to be calculated in the future, we memorize it. Basically we store it in a dp, that answer, and whenever we hit that index function, then we directly just assign with O of 1 time complexity. So basically our time complexity here will become O of n. From 2 to the power n, which is an exponential function, we are coming down to the linear time complexity, which is a much more efficient approach. So this will work for this. So we just submitted it and our answer is submitted. And the next one is we have written our solution from 0 to n, so we can write our solution from n to 0 also. So n to 0, how it can be written? dp will be same, just we need to like traverse from index n minus 1, and instead of this index greater than index greater than the n, index greater than n, we have to the condition should be -1 -0. Sorry, the condition is like index less than 0, and we will be going, instead of plus we just need to do minus here, and all other condition will remain the same, and our answer is done. We are starting from the index -1, n minus 1, and we are going till 0, and our as we are going till 0, if we took the n minus 1 thing, then we are going to index -2 things, and if we are not taking the n minus 1, then we are going to index -1. So we can take the like one step back, and if we take the index, then we cannot take the one step back one, we need to go to two step back, because adjacent one we cannot take. Then the next thing we can do is we can write our tabulation approach, which is basically a top down or bottom up. We can write our tabulation approach here. So in tabulation approach, we need some initial conditions, like dp of 0, we have to make it 0, and dp of 1, we have to make it like nums of 0. And I don't need this helper function now, and I will calculate from I equal to 2 to I less than equal to n, I plus plus, and then I can calculate my dp of I is equal to maximum of, if I take it like nums of I minus 1. Why I am taking I minus 1? Because here dp of 1 represents we are taking from nums of 0. So dp of 0 have our initial condition as 0. So why I wrote this 0 also? Like in the previous in the recursive solution, you have seen that I have written one base condition. So base condition was from n minus 1 to 0. I have written index less than 0. We are returning 0. So the same, to replicate the base condition, we have to give our initial condition, give one initial condition based on that. So here our initial condition turns out to be dp of 0 equal to 0. And then, like in this dp of 0 and dp of 1, in this dp of n, what we are calculating is, like for the dp of 1, if dp of 1 is there, then what will be the answer? So if dp of 1 means only this 1 is there, then only this 1 is there, you just forget out all these things, only 1 is there, then what will be the maximum answer? We can only get 1. And the next step, in the dp of 2, what we will be calculating, if we have only 1 and 2, what will be the answer? So if we are taking 2, we cannot take 1. So here we are taking the 2, so we are adding it, and then we cannot take the one thing. So I need to do here I minus 2, dp of I minus 2. And if I am not taking this 2 thing, then I can take the 1. So I am only doing I minus 1. Then I can return dp of n, because at dp of n we will get our maximum amount which we can draw from the houses in a night. So dp of I all done, dp of okay, correct. And I will run this, and okay, something wrong here. What is wrong? I am starting from I equal to 2, I is less than equals to n, and I plus plus. Okay, I am going from 2 to n. And here address, it is telling us that we are going out of bound. Sorry, I have to make the dp n minus 1 so that dp of n will be calculated. Okay. So here we have our answer here for tabulation approach of 0 to n. So if the other way, if you want to go from n to 0, then for dp of n you need to give it 0, and dp of n minus 1 you need to give the n minus 1 here, last index number, and you need to calculate the dp from index n minus 2 to 0, and for dp of I in the 0th index we will have our answer, and dp of I plus 1, this will be dp of I only, nums of I, and if nums of I have taken, then I need to go to I plus 2. If I haven't taken, I need to go to I plus 1. So for n minus 2, if I calculate it, I will get my answer here. I will submit it here. So this brings to the end of our solution. Like I have explained you 4 solutions, like tabulation and memoization approach from 0 to n and n minus n to 0, and for this tabulation and recursive approach both from n to 0 and n minus 0. And thanks for watching.